Now on this deck I noticed a problem with the tape path. Certain tape guides were not correct. This one was pulling the tape towards this edge when the tape was in play. So when it was in rest like this, it was okay, but as soon as you hit play, it would jerk to this side and yeah, scrape this side of the guide. So, well, the manual states clearly that there are 6 tape guides here, here, and here, and then on the other side, so that makes 6, of which the middle ones are the fixed ones, so that's the reference point for all the others. Now, that happens to be the one that I just pointed out to you, so that's the reference point, so that's not the one you adjust. You adjust this one and you adjust this one. So I looked at the configuration again, and this is the top one. This is then the reference point one, and this is the third one. So I saw that the problem was with this one. With this one. And so I adjusted the height of this. There's a screw here, and you can adjust it very slightly, but very precise. And when I did that and checked what happened here, well, it's now perfect. Sorry, I checked what happened here. It's now perfect, so I will demonstrate when I put it in play. Look at the tape. Nothing happens except for that the tape, of course, is placed against the heads, but it does not jerk to one side anymore, so it plays perfectly. So that has been corrected. So now we're going to measure the tape tension. Tape tension should be for the back tension 75 and for the take-up tension 65. And you can measure it at these test points, or you can measure it with a tension analyzer. And well, look what we have. A tentelometer. So let's go. First I'm going to measure the back tension. As you hopefully can see, that it's around 80. Oh, it's around 80, 75, 80. And it should be 75, so that's okay. And then the take-up tension. I don't know if it's visible, but it's around 70. Jitters a lot, around 70. So the tape tension is successfully adjusted. Okay, now we're going to measure the frequency, whether it's running on the correct frequency. Now I do not have a specialized speed measurement tape, but I'm going to use my normal bezugsband that I have, because that has a 1000 hertz tone, and I'm just going to play that and measure that with the frequency meter that's on this device. It's not only a wow and flutter meter, it's also a frequency meter, and we see how close this gets to 1000 hertz. So let's play that.
Es ist nach beiliegender Beschreibung. Pegeltonteil 1000 Hertz. Bandfluss 320 Nanoweber pro Meter.
So it's maybe a little bit off, but this is also an old tape. Maybe may have been stretched a little, but I think it's close enough for me. Close enough to 1000 hertz exactly. So I think the test has succeeded. So right now we are going to measure wow and flutter the tape, and we're going to measure that with this wow and flutter meter, and we've got an output signal that's going to the tape deck, and it's already coming in on the left channel, as you can see, but we're gonna measure it while playing it back, while recording it. So put it in record. There you hear it. It's recording it and playing it back. See, so it's the recorded signal. I'm gonna demonstrate it with adjusting the tape switch. Anyway, well, this is of course measuring now. I'm going to show you that it's on the DIN setting. I'm going to measure the DIN setting. That's 3150 hertz, and like the American and the Japanese and the French standard is 3 kilohertz, as you see. So what we're going to measure DIN. I like DIN. We're going to put it on DIN here. I'm going to put it on weighted, and well, the range is already on 0.1, and it's measuring this. So of course it fluctuates, but let's say it's around 0.08, 0.09, and I'm gonna look up what the specs say. So I'm gonna pause this. Okay, I think I found it. This is the service manual again, and here you see the wow and flutter. I measured it at 19, and I thought it was 0.06. Well, I measured 0.07, 0.08. So it's a little bit not up to spec anymore, but well, it would be nice to check the 0.035 at 38. Let's do that. I have to hook it up again. There it is, and put it on the fast speed. Now let's see what it measures. That should be 0.035, and it is now 0.06. Well, it fluctuates a lot, but you get the point. It's it's relatively close to the factory spec that it had to be 35 years ago. So I'm very happy. Okay, next up is the adjustment of the capstan motor control circuitry, and that is to check if the direct drive motor gets correct phase pulses. So I'm gonna measure that and adjust that. You have to thread a tape and play it in the middle of the tape and connect dual trace oscilloscope to 2 test points, put them on DC position and play the tape in the middle, as I said, and then the relationship between the sawtooth that you measure and the pulse that you measure should be around around halfway the sawtooth. So here are my probes connected to the 2 test points, and here is my scope. Hope it is visible. Let me switch off that light. I hope that it's visible that here you see, of course, the sawtooth, but here is a pulse. Here you see it like this. That's better. So this pulse should be, well, around here, just like in this picture. So this one has to be adjusted. First you have to adjust the peak of the sawtooth to be 10 volts. So the sawtooth has to be between 5 and 10 volts. I've checked that with the oscilloscope and that is correct. So I don't have to adjust this one. I have to adjust this one and get the pulse in the middle of the sawtooth. So we're going to try to do that. Here is the hole. It also says phase adjust, so that is convenient. Okay. And we're gonna see what happens when I turn it. That's not the correct. I think this is about right. So I've adjusted this, and well, it's perfect now. Since I have adjusted the capstan phase, I actually want to measure the wow and flutter again. So let's do that. Here I have the meter. It's the signal. And this is the measurement now on 19 centimeters per second. And as you can maybe remember from before the adjustment, it was between 0.06 and 0.08. And now it's after the adjustments, and I would say it's around 0.05. I think it's become less. I'm not sure if it had a direct effect on the wow and flutter specifications, but it seems better now. And also it's more in the range of the specs from the factory. Switching the deck to 38 centimeters now. And let's see if that is even better. Well, actually it doesn't matter that much. This is also around 0.05. Now I'm putting it on the lowest speed, 9.5 centimeters per second. And you can see I have to go up a scale. So from 0.1 I have to go to 0.3. And on that scale it's a lot. I haven't measured it before, so I'm not sure if it's better now, but anyway, this is another good reason never to use these low speeds. Okay, so we're going to take a look at the playback heads now. Before any calibration of what sort, like level or playback level or recording level or even recording head adjustment, the very first thing that has to be done is of course that the playback heads need to be exactly right, and that means with the correct azimuth. So we're gonna do that here. Well, there are a lot of things that you can adjust. I'm only going to bother with azimuth, and these are the screws that I need to adjust. For my purpose I will only need B azimuth adjust, and of course you can adjust the height and the tilt and everything. Well, here they say play the test tape and adjust screw to have the maximum output on a voltmeter. Okay, that's not all very nice, but I'm going to do it this way. So when the heads are exactly in phase, that means that the head is tilted and azimuth correctly, then the signal will be like this. And if there is an error, the head is a bit queer, then the phase will look like this and this. Essentially, you make the x-axis on the oscilloscope use the left channel, and the y-axis use the right channel. And when the signal is 100% in phase, then the signal will be a straight line on the 45 degrees, of course. And all this is a very severe error. So we're going to check that here. I've connected the oscilloscope again and set it into the XI mode. I've loaded the MRL test tape this time. I could do it with the BASF test tape, but I'm using the MRL test tape. And it's playing now the 1 kilohertz tone for azimuth, and it will proceed with the 10K tone for azimuth. And this is the screw that needs to be adjusted. Well, let's play the tape and see what happens. Hope that it focuses. This is the announcement. Oh, that's very bad. It's only on 1K. I'm gonna try to make that a straight line. Okay. Okay. Well, that worked. Oh, that was very, very bad. And now it's going to do that in 10K. Oh, that's not bad. Oh, that's not bad at all. Okay. Not sure if I can improve on this. No, not this way. And no, not this way. So it was perfect now. It's difficult to put it back. I'm gonna play back the 1K tone, because that was better. Oh, a little bit more rewinding. Yeah, this is perfect. This is perfect. Oh, I think the playback will be a lot better now, because the playback missed a lot of a lot of high frequencies. So well, let's see how it. I'm hoping it will be better now. Of course, there's also a 4-track playback head in the device, and that's located on the left side. And I assume, it doesn't say, but I assume that screw B is again azimuth, because, well, they have numbered it the same way, so I think it's screw B again. So that should be... it doesn't match up with the drawing. Not at all. The head is here. Oh, let's see, these are the ones. Yeah. So it is this one. Yeah. This should be azimuth now. Okay, I have rewinded. Let's see. Oh, this is the first 0 dB tone. Now, I can see here already that it's not so good, but let's wait for the 1K tone. Where is it? Ah. There it is. Okay, here we go. It's also way off. This is a lot better. Okay, now let's wait for the 10K tone. Okay. Well, I don't think I can improve that much. No. No. Let's play it back to the 1K tone. Yeah, it's perfect. This is okay. So, actually, I am quite curious to see how it performs in playback now.